Hello my fellow learners, we are now here another set of our discussion of in the geometry lesson, and that is finding the arc length of a circle. Hope you enjoy this. Now, since we're talking about this circle, so this is now the circle that we have, and then if we have here a circle that cut with two parts, and we have here this one, the first one is what you call a semicircle, and the other one is another set of semicircle. And then if it is another set that can be cut again, so we now have quarter circles. We have 4 quarter circles. So now we have here, how do we able to get the value of a certain part of a circle, its length, and that is what you call the arc length. So as you can see in this given, we have here given the orange part. This is what you call the arc length. The whole part of this is what you call the circumference of a certain circle. Now, so we now have here the arc length, and provided here is we have here this one here is the angle given, and the angle that represented by this is what you call is a central angle. The central angle is indicated as an angle whose the apex or the vertex. So this is now our arc length represented by S. So here we goes that in order for us to get the arc length, we now have here a formula which is S is equal to R theta. Considering that we have previously we have the perimeter of a circle and that represented by circumference, we have here 2 pi r. So in other words, the theta here, this is the theta, this is the theta that represents the angle measurement, whether in radian measure or in the degree measure. So in other words, this is now our theta representation. And so, recalling ourselves that we have here the circumference, the whole part is the circumference, but if we have just a part of a circle, and we now have here called as a arc length. To get the arc length is we now have here r times the theta, the value of the theta. Then consider now here we have here a circle that divides into 4 equal parts. The theta here is a 90-degree angle, because as you can see here, this is a 90 degrees. So therefore, we now have here the theta itself is 90 degrees. And then if we're going to make use of this theta here, if it is in the degree part, so we now have here change that one into pi. And it seems that if we're considering this, the whole part of this is a 2 pi r, the whole part. So therefore the 2 pi here is just considered as a whole length represented by the 2 pi. So therefore this one now is since it is just divided into 4 equal parts, and we now have here this one is 2 pi as a whole, then this one here pi over 2, pi over 2, pi over 2, and another pi over 2. So therefore this is the 90-degree angle is equivalent now to 2 pi over 2. Take note with that. And if we have here another set, so this is now a 180-degree angle. So therefore this is now considered as pi over 2 plus pi over 2, and this is now equivalent to pi. And then if we have here another set of 90, which is equivalent to 270, so therefore the 270 here is now equivalent to pi over 2 plus pi over 2, and we now have whole pi plus another pi over 2 is 1 and 1/2 pi, or just to say 3 pi over, no, sorry, it is not 3 pi over this this is not 3 over pi but 3 pi over 2, or just we say 3 halves pi, and that the whole part is 2 pi that we have, if and given that the radius that we have in a circumference. So we now have to recall ourselves in dealing with such thing that we have done here previously. So 90 degree is equivalent to pi over 2 in the radian, 180 degree is equivalent to pi, 270 degree is equivalent to 3 pi over 2, 360 degree is equivalent to 2 pi. Now, how do we able to cater if we don't have a part where it is not a 90 degree? Let's say we have here, let's say we have 60 degrees, 120 degrees, 210 degrees, 300 degrees. How do we able to cater this one? So if we have to solve this part here of 60 degree angle, we could see 60 degrees if we're going to convert that one into radian. So we now have here 60 degrees times 180 pi over 180, because accordingly as far as the 180 degrees is concerned, it is just equivalent to pi. Take note with that. So as we convert this one, we now have here divisible by 60, so this one becomes 1 and this one becomes 3. So the answer now of this is equivalent now to 1 times pi, and that is pi, then 1 times 3 and that over 3. So we now have with that. So next is we have 120 degrees. So to get the 120 degrees is 120 pi over 180 that we are going to multiply with that, and so we have this is just equivalent to divisible by 60. This is just 120 divided by 60, and this is, we have here 2, 180 divided by 60, and we have here 3. So we could say further that this is the 120 is equivalent now to 2 pi over 3. Then if we have here 210, so 210, now we now have here, then again 210 pi over 180. So we now have here divisible by let's say this is just divisible by 30. This is let's say 60. No, it's 730. So 210 divided by 30, and that is 7. Then 180 divided by 30, and that is 6. So we now have here 7 pi over 6 as we know it. And then we now have here another part which is 300. So 300 degrees. So let's say 300 times pi over 180. So divisible by this. Yes, it's correct. This is divisible by 60. So 60 at 300 divided by 60, and that is equivalent to 5. Let's proceed to how to convert if we are going to have to convert it from radian to degrees. So let's have here another set of example. Let's say pi over 3. So to get the pi over, if we're going to convert pi over 3 to a certain to degree, so we now have here multiply pi over 2 180 over pi. So we now have here cancel. So 180 over 3, and that is equivalent to 60 degrees. That is how to be heated in dealing such with this kind of radian that can be converted into degree. So another one is 7 pi over 4. So 180 over pi. So we now have here cancel the 180, and we now have here, this is the 180 divided by the 180 is divisible by 4, so this is just the same as 16 60 60 60. No, this is not 60 anymore, but so 4 divided by 4 is 1. 180 divided by 4 is 45. So we now have here 7 times 45. So 7 times 45, and that is 315 degrees. So 7 times 45 is 315 degrees. So the equivalent value now of 7 pi over 4 is 315 degrees. And then if we have here another set of example, which is 11 pi over 6. So we now have here multiplied to 180 over pi. So we now have here cancel. So this 6 is, and 180 is divisible by 6. So we now have here 30. So 11 times 30, and that is 330 degrees. So this is now how to convert radian to degree, and then the first one is degree to radian. So let's now have to get things clear in finding the arc length. So let's say this kind of example, finding the arc length. So we have here an example, a circle has radius 8.2 centimeter. Find the arc length intercepted by the angle each of the following measures. So we now have here 3 pi over 8, and then we have here 144 degrees. Take note, why do we need to have to convert both degree to radian or radian to degree is that for us to be able to get the arc length, because the arc length is represented into radian. So whatever it takes, if it is degree, we are going to convert it into radian. Okay? Now, so we have here a given example. This is 3 pi over 8, the central angle. So we now have, like for instance, we now have here 3 pi over 8. So if we're going to have here, so the arc length is represented by r, s is equal to r theta, where the theta must be in the radian. So since the given is in the radian, which is 3 pi over 8, so we now have here given 2. So replacing all the values of the radius and the theta, so we now have 18.2 replacing for the r, then theta is 3 pi over 8. So we now have here 54.6, because 18.2 times 3 is 54.6 times pi all over 8. So this is now approximately, then take the pi as approximately to 3.1416. So 54.6 times the 3.1416, then divide by 8. So we come up with round to the nearest hundredths your answer. So we now have an arc length of the given figure, which is equivalent to 21.44 centimeter. Now let's consider also that if we have the central angle to be measured as 144 degrees, so we now have here 144 converted first into radian before we go further with the to get the arc length of it. So we now have here 144 times pi over 180. So we now have here 4 pi over 5, because this the 144 180 is divisible by let's say 4, also divisible by 12, I suppose. Yes, it's divisible by 4. Then as we go through, we come up here, uh, let's say 144 to 180. So we now have here, I make use of the continuous division for us to divide this further. So this is divisible by 4. So 144 divided by 4, and it is equivalent to let's say, what is the equivalent value? 144 divided by 4, let's say 36. So 36. Then this one is 65. Okay, it's 65. 180 divided by 4, let's divide by 4, and that is 45 rather, not 65. So this is the 36 and 45 is divisible by 9, so this is 4. 36 divided by 9 is 4. Then 45 divided by 9, and that is 5. So that is why, see, it is now simplified as 4 over 5. Okay, so 4 over 5 radians. So we now have, in order for us to get the arc length of the certain 144 degree central angle, so we now have here, replace the r to be 18.2, and then the theta is 4 pi over 5 cm. So 18.2 times 4 is 72.8 times the pi all over 5. Then it is, as we go through with it, and it is approximately equal to 45.74 centimeter. Okay, we now have tried to another set of example, and the example here is a rope is being wound around a drum with the radius of 0.8725 feet. How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? So we now have to consider a drum that is 39.72 degrees, then must be converted first into radian, which is 39.72 times pi over 180. Then we now have here the radius is 0.8725. So we now have here 39.72 times 8.725 times 3.1416 divided by 180, and we now come up with 0.6049 feet. So the rope will be wound around the drum by 0.6049 feet. Okay, so let's proceed to another set of example. Find an angle measure using the arc length S is equal to r theta. So the two gears are adjusted so that the smaller gear drives the larger one. If the smaller gear rotates an angle of 225 degrees, through how many degrees will the larger gear rotate? So take note that this is just this relative to the science, to the physics. So the rotation is the same as the rotation of this, or the arc length of this is the same as the smaller one. So we now have to find first the smaller one. So find the radian measure of the angle, then find the arc length of the smaller gear that determines the motion of the gear. So we now have here 225 as the smaller one. So as we convert this one, it is just equivalent to pi over 4 or 5 pi over 4 radians. So as we can see, if we're going to have here, or the arc length of it is, we now have here, since the radius of the smaller gear is 2.5 centimeters, so we now have replaced 2.5 then times 5 pi over 4. So 2.5 times 5 is 12.5, then pi over 4. So we now have here 25 pi over 8 centimeter. Now take note that an arc length with this length on the larger gear corresponds to an angle degree measure. So meaning to say that the arc, whatever the arc length given here in this portion here, is this the same as the big one for us to be able to rotate it equally. Now the gear one. So the S now for this is 25 pi over 8, then the radius is 4.8, then we now have here theta. So for us to be able to get the theta for this is we in this case, so 25 pi over 8 is equal to 4.8 theta. So from this we are going to divide both sides by 4.8. So theta now further is, we now have here 125 pi over 192. So if we're going to convert further, so that 125 pi over 192 to degrees, and we now have 180 times pi. So if we're going to multiply to convert this one, so approximately it is equivalent to 117 degrees. The larger gear rotates through an angle of 117 degrees. Okay, so goodbye for this moment in this discussion in finding the area, finding the measurement of the arc length of a certain circle. Hope you enjoyed this further. Then take note for the next video lesson that talks about area of a circle, of a sector of a circle. Hope you enjoyed another set of the video. Goodbye for now. See you then.